Okay, so this is the second lecture in the cognitive revolution, or at least the second video in the cognitive revolution lecture. We've talked about cognitive revolution as a science when it started off, the problems that a discipline like this faces, integrating and trying to make sure that every practitioner is talking to each other and not past each other. So now I'm going to give you a little bit of background in philosophy of science, which is my area. Hopefully the reading would have also made this clear. I'm not doing anything new in this presentation that I didn't do in the reading, and vice versa. Okay, so we're moving on to philosophy of science. In the reading, in the chapter, and here I'm going to focus on three different aspects of philosophy of science that are major topics, some of which are still actively being debated, others of which are now just used as sort of background material for the active debates. So the topics are realism, explanation, and reductionism. The realism, anti-realism discussion is about whether science is getting to the truth of reality in some way independent of our minds. I think this is the kind of question that is super obvious to some people, and sometimes the ways that the answer is obvious are completely different than how it is to other people. So I love actually seeing how people disagree on this one. Explanation. I remember when I first started studying scientific explanation, I thought that I must be surely missing something. It seems so simple, and yet people spend so much time on it. I mean, explanation really is just what you think about explanation. Like when you're out late and your parents demand an explanation, you know, they want a reason. They don't necessarily want you to give a causal step-by-step of like how you drank too much and were out with all of your friends and, you know, doing horrible crimes. Usually there they want specific moral reasons. You can, however, give a causal explanation, like a car rear-ended me, something structurally prevented me from coming home early. That's just how an explanation works sometimes. Scientific explanations, there's two things that makes this debate interesting, like what makes them specifically scientific and what makes scientific explanations specifically explanatory. So we'll talk about that. Reductionism is sometimes thought of as a subset of explanation. It's a particular kind of explanation. So we'll talk about that. And then we'll also talk about when there is too much or not enough data to yield one specific explanation. So pretend you can read the word approximately. Scientific realism, we're going to start with that one. And that's the thesis that what science dictates is approximately true. So on the left, there is a thought bubble, and there's a general theory. There are these entities which I've remarked are represented with balls. And then there's relationships which I've represented with lines connecting them. Now, suppose you have a theory about plate tectonics, and the theory says that there are plates in the center of the Earth. They relate to each other in such a way that when they rub up against each other, that one goes under, one goes over, one crashes into the other, or they push each other back, right? There's a couple of ways they can interact. And then suppose that reality says that that is actually true. You go and you investigate, and any human or any alien investigating Earth would come to that conclusion too. It's tricky that I've already like preloaded it that particular way because I've talked about intersubjectivity. Like agreement between subjective or people looking at this rather than objective reality. It's kind of hard to talk about objective reality, but suppose that it actually just really is the case that there are plate tectonics. In that case, a scientific realist would be right. The theory and the entities and the relationships accurately represented reality. So let me move on to a specific example here from cognitive neuroscience. Alvarez and Squire have this model of how memory works. And the idea is that areas in the cortex are mediated by hippocampus activation, which is to say that if you had some particular damage to your hippocampus, you would not be able to remember things. You might still remember old connections, old memories that you made, but not these. So if we're studying this particular model, and we say memory isn't located entirely within the cerebral cortex, it also has a relationship to the hippocampus, you would say, okay, if you are a theory realist, they were just right. That was the correct view of the world. If you are an entity realist, you might not be convinced that they showed their case. And in fact, I didn't give the details of this particular case, but maybe the hippocampus has some relationship with memory, maybe it influences in some way, but it does it because it's influenced by the thalamus or by something, right? Alien rays. Finally, you can be a relations realist. So I use the term relations, even though in the literature and philosophy of science, they call it structural realism. I just think that might be confusing to you all. So we'll call it relations realism, where the processes are important, right? So the difference between entity realism and relations realism is that the entities, we're talking about something that we think the science has gotten right, a particular entity exists. Relations realism is about a relationship that exists. And usually in the literature, when they talk about this, they talk about, well, the mathematical equations are still true, even if we were wrong about what they represent. Newton thought that gravity was a force. Einstein thinks that it's a property of matter, bending space, but the equations still work. So the relationship is still correct, even if the entity is not at all what Newton thought that it was. Now, that's scientific realism. And remember, you can be a realist about any theory or any entity or any relation. If you are a scientific realist, you do not need to be committed to being a realist about everything that science says all the time, right? Anti-realism. We are all anti-realist about something. And so the scientific anti-realist is a person or a view about the way that science works, or the way that some aspects of science currently work. Some theories are not, strictly speaking, appropriately true, approximately true. There's a couple of arguments for this. One of them is fallibilism, and that is the view that scientists have been wrong before. In fact, every scientist before the present has been wrong, just like every religion, we think that people in the past that believe things that were different from us, many of them were literally just wrong. And so if you take that seriously and you say, okay, they were wrong, but they felt as justified as we currently feel, and they had lots of evidence, that should draw you to the conclusion, the fallibilist argues, that some of our theories may be false. And so you shouldn't be very comfortable that this particular theory is false. Whether you're a weak fallibilist or a strong fallibilist is basically how convinced you are by the apparent falsity of any particular belief, of any particular theory. So I have shown a lot of videos of thinking about the mind. Let's say they were all wrong. Every previous person that had thought about the mind was wrong. Therefore, the weak fallibilist says we should be ready to believe that we could be wrong. And the strong fallibilist says, no, we probably are wrong. The other argument against realism is instrumentalism, where people say, well, actually, that's just not even the point of science. Scientific theories aren't meant to reveal reality. They're just meant to be useful. So instrumentalism. If science, all of the evidence, when I talked about the tectonic plates or the models of memory, I'm just saying that they're very useful. Any purported claim to them actually being real is going a bit too far. So hopefully that makes sense to you all, right? The view that you could be a realist about a theory, you could be an anti-realist. You could think that the theory isn't in the business of being accurate, or even if it is, that it chances are it's probably wrong, because we've been wrong about everything before, even things that we were very confident in. There's many accounts, so moving on to explanation. There are many accounts of explanation. I'm focusing on two. And I want to point out that unlike realism and anti-realism, these are not in strict opposition to each other. They are two different notions of how explanations work. So in the causal explanation approach, the nature of explanation reveals how objects made each other happen, how interactions came to be to cause things to be the case. If I tell you that the hippocampus is involved in memory, I say that it has a causal relation to memory, like it causes some memories or is caused by memories. Well, that one's weird. It causes some effect on memory. This is in contrast to a pragmatic explanation, where the point of an explanation is just to talk to other human beings. So you can have a pragmatic explanation that is non-causal. So it's the kind of explanation where you're just trying to get you give a person a slightly incorrect view of the world, or you don't describe causes at all. You just say these things occur. You don't know what causes them, but the aim is to try to get people to understand reality. You could also have causal explanations that nobody understands, right? So their causal explanations and pragmatic explanations are not in the same business. Pragmatic explanations are about understanding. Causal explanations are about allowing you to control the world. If my causal explanation of memory is correct, then I can destroy your hippocampus and affect your memory. I have that control. If it is incorrect, then I can destroy your brain and like fail to destroy your memory. So that was a bad explanation. It is possible to have a causal explanation no human being understands. It's actually not even that difficult. You could just like load all of the orbits of all of the objects orbiting the sun and know that there is a causal explanation for why they are in the particular configuration that they are, but no human being could do that math. It would have to be like a computer that does that math. I want to talk about some phenomena, and I'm going to represent it by GIFs. So suppose you see a window being broken, somebody throwing an object through it. The example from articles is a rock, but here it's a water fountain. You see the water fountain being hurled through the window, breaking the window. So you say, okay, my evidence, I reason that nobody like secretly broke the window before the water fountain went through it. I have really good evidence that the window wasn't designed to shatter. It's not the case that like water fountains can't melt glass beams. So I conclude, I determine that the water fountain broke the window, okay? I have enough evidence and enough reasoning for that. Sometimes I just see the window being broken, or the window has been broken. And I have evidence and I have good reasoning. I can draw conclusions about why the window was broken. But there's a number of conclusions that are reasonable from my evidence and reasoning. So if in the water fountain case, the evidence determined my conclusion, in the case where there's not enough evidence or not good enough reasoning, we might say it underdetermines the conclusion. I don't know why it's not animated here. Okay, underdetermination. Lastly, it may be the case that something was bound to happen. So maybe 3 people threw rocks at a window, or many water fountains, or the car fell under the ice and spun out of control and then exploded. Like the car, there were many independent lines of evidence that tell you that the car is now unusable. Right, so this is overdetermination. This is how evidence relates to explanation, right? So sometimes you have not enough evidence in underdetermination cases. Sometimes you have just enough evidence, and sometimes you have too much evidence. I think most of the time, underdetermination is what we have. We just don't have enough evidence. All right, the last thing that I talk about in the article is this idea of reductionism. And like with realism, there's many aspects that you can focus on. You can focus on theories. You can focus on entities. You can focus on explanations or methodologies. And people have focused on all of these. So a theoretical reductionist will say that there is some way of bridging theories of the mind with theories of brain state. The computational view of cognitive science is something like that. I think theoretical reductionism has lost a lot of adherents in the past couple of decades. There are still some people that are that. There's entity reductionism, and that is the view that mental states simply are brain states of a certain kind. In the philosophy of mind reading, this would have been called token identity, right? So single entities just are other kinds of entities. There's explanatory reductionism, which is the view that you don't have a fully complete explanation until you have some other science undergirding it. So we don't understand schizophrenia, for example, until we have a biological diagnosis of it, not just a psychological diagnosis. And then there's the methodological one, which I think is less controversial than some of these others. And that is the view that we should try to find lower level explanations, appeals to biology rather than psychology, if possible, whenever possible. For every reductionist, there's an anti-reductionist. The theoretical reductionists with respect to neuroscience might point out, or sorry, the theoretical anti-reductionist might point out that there's no neural basis for particular beliefs, and it's actually hard to even imagine how that could be. We'll get into that later on in the semester. Entity anti-reductionists will point out that there are some things that only make sense at the higher level, the abstract level. There's many ways that you can have PTSD, but it's there's diagnostic, there's particular patterns that PTSD results in, and those make sense independent of whether there's many common neural bases. Explanatory anti-reductionists will point out that there's all of these appeals to lower level have actually, like, especially when it comes to mental illness, have failed. And the methodological anti-reductionists will point out that actually there's a lot of focuses on lower level, like paying attention to lower level sciences that have been less successful than focusing entirely on more remote or abstract sciences. So you can be a reductionist about everything, but you can also be an anti-reductionist about some things. You can decide, for example, to be a reductionist about beliefs, but not about diseases or psychological diseases or that kind of thing. I don't know why you would, but you could. So that was it. That was the last bit of philosophy of science. In that lecture, we talked about cognitive science as a field, integrating, and then a background in philosophy of science. Hope that worked. Talk to you later.